Okay, so let's answer this. Given y equals x cubed minus 3x squared plus 4, find the relative maximum or minimum of y, or the function, using the second derivative test. That's exactly the given problem, right? Okay, so solution is, what is the first thing that we have to do? Derivative. So we first find dy over dx, and this is equal to 3x squared minus 6x. The critical values will be coming from the dy over dx equal to 0. So solving for 3x squared minus 6x equal to 0 means factor out the 3x. X minus 2 is equal to 0. From here, it is very evident that x must be 0 or x is equal to positive 2. So these are our critical values. Okay, once we have the critical values, since it was mentioned that the test that we're going to use is a second derivative test, we go straight to the second derivative of the function. The second derivative is d squared y dx squared equals 6x minus 6. So we're going to test those values in the 6x minus 6. If x is equal to 0, 6 times 0 minus 6 is equal to negative 6. A negative second derivative at a given number means you will have a relative maximum at x equals 0. Then, if x is equal to 2, that means 6 times 2 minus 6 is equal to positive 6, and that will give us a relative minimum, meaning to say at x equals 2. So what will be the relative max and the relative mean? The relative max happens at x equals 0, but where are you going to use x equals 0? Where are you going to use that? In the given equation or function, x cubed minus 3x squared plus 4. So you have x cubed minus 3x squared plus 4. When x is equal to 0, it means 0 cubed. 3 times 0 squared plus 4. So that means this is equal to 4. So the relative maximum is 4. What is the maximum point? It means 0, 4. Okay. So this is maximum, relative maximum point is 0, 4. While this 4 is the relative maximum value. Then, when x is equal to positive 2, so relative mean at x equals 2, that means 2 cubed minus 3 times 2 squared plus 4. This will be equal to, is it 0? That's 8 minus 12 plus 4. So this is equal to 0. So the relative minimum value is 0. The relative minimum point is 2, 0. So relative minimum point is 2, 0, and 0 is the minimum point, minimum value. Okay, questions? And then we go to the second one. So in the second one, you are given y equals 2x cubed minus 6x squared minus 18x plus 2. but the domain for this will be restricted to negative 2 to 4. Meaning to say, if you will be graphing this function, we will be graphing it only from negative 2 to 4. So it will be cut from negative 2 up to 4. The question is, find the absolute maximum or minimum at this closed interval. So in the first one, there was no restriction. Let us see how are we going to apply the derivative test for restricted domains. Okay, in particular in a closed interval. Okay, let us first answer this using the first derivative test. Okay, so that we can practice on using the first derivative test. First, by first derivative test, f dt, okay, they always have the same first step. And the first step is to get the dy over dx, the derivative. And we have to set this to 0. Well, the first derivative is equal to what is the first derivative? 6x squared minus 12x minus 18. Okay, and we have to solve 16 minus 6x squared minus 12x minus 18 equal to 0. Before we factor, we can see that all numbers are divisible by 6. So this will be reduced to x squared minus 2x minus 3 equal to 0. So if we factor, we have x minus 3 and x plus 1. That means the critical values are x equals 3 and x equals negative 1. Okay, how are we going to consider the restricted domain? The restricted domain can only allow critical values under that domain. So we check, is 3 part of negative 2 to 4? Yes. Is negative 1 part of negative 2 to 4? Yes. So we have to use both numbers. Okay. So once we have the critical values, in the first derivative test, all we have to do is to get their corresponding value y. So x equals 3, find the y value. X equals negative 1, find the y value. And then you add those endpoints of the given interval. What is the y when x is negative 2? And what is the y when x is equal to 4? Then, this is where we compare values. Which one is the highest? Which one is the lowest? So we will be able to get the absolute maximum or absolute minimum. Okay, so kindly work on finding the corresponding y. Okay, what is y when x is 3? What is y when x is 3? Negative 2? Negative 53. 52. 52. When x is negative 1, 12. And then when x is negative 2, negative 2. This. And when x is 4, negative 38. Okay. So what will be our absolute maximum? Absolute maximum will be at x equals negative 1, which is y equals 12. Okay, and the absolute minimum rather is the lowest among the values, which is negative 52. Now we can further support this, although because we have only x equals 3 and negative 1, we can further support this by having those numbers, negative 2 and then 4, we have negative 1 and 3. Another way to look at this is to analyze what is happening to the first derivative in each interval, okay, in these intervals. Is it positive or negative, positive or negative? Okay, and let's support the x equals negative 1 being the absolute maximum. Okay, so the derivative that we obtain is 6x squared minus 12x minus 18. 6x squared minus 12x minus 18. Help me in finding the value of this derivative. We are using x equals 3. Use a number immediately before 3 and after 3. Okay, say x equals 0. It will be negative, right? By just substituting 0 on x, it becomes negative 18 since it's a negative. What if we place number like 3.5? Use your calculator and put in 3.5. Is it a positive number or a negative number? Positive. So it means a negative slope, so it's going down, and then after that it changes into a positive slope. So indeed, we have x equals 3 will give us a minimum point, so it is supported by analyzing the derivative. And we can expect the same thing with x equals negative 1. If we focus on negative 1, well, we already have this side as decreasing. If we will be testing the behavior of the graph before negative 1, we will be expecting an increasing function or increasing graph. Hence, we have a maximum point there. So that's how we support. Okay? But sometimes it's automatically be that way even if without showing that case, because we only have 2 critical values. So the lower the value that you obtain, it means it's a lower value. And then the higher or the highest value that you obtain will give you the highest value. Okay, questions? So we have absolute for this one, and then we have the relative in the previous one. The process are similar.